Okay, before you explain your trick, Tom, we'll point out that through the magic of video editing, we replaced that little yellow wire that was helping us out with ground with a little green one over here. You see, it starts there and it kind of comes down. Same place the yellow one was. And we've conveniently wired up your trick.
Yes, and it's actually it's very important for that ground rail to be
clean.
All
right, so why don't you tell us what you've done?
Okay, so I've replaced that connection to ground with now this bias network. These are 220K resistors forming a voltage divider. So the voltage here is 1.65 volts.
I want to share with you my pointer. It's very high tech. It's a high tech.
Thank you.
High tech pointer.
Yes, so you see this point right here is at 1.65 volts. And that should actually set the bias here at 1.65 volts.
So you added a little resistor bias network.
Yep.
And what it does is it sets the non-inverting terminal of the op-amp to 1.65 volts instead of DC, instead of ground.
This is exactly like the virtual ground trick, except this time we set whatever voltage we want.
And that's because we know that this is an inverting amp, and so we want to raise sort of the output point.
Exactly. We want the output to be floating, varying up and down between 0 and VDD.
Okay. All right. Okay. What else did you do?
But I also added
the magic.
The magic. This is a capacitor, a 1 microfarad capacitor, and I connected it between the electret output and the resistor going to the inverting input.
So the capacitor is that magic that cuts out the DC.
Exactly. That capacitor is that magic that filters out all the DC, so we can actually pass a very small signal to our amplifier.
All right. So of course, you guys at home, we assume you don't know what a capacitor is or how it works, which is exactly the point, because we want to motivate the videos that come immediately after this by delving into all the coolness of capacitors. But that's what's doing. And the question that will come up soon is, why does it do that, right?
Yeah, it's actually a really neat circuit element.
What's the magic? But for the moment, we're just using it as magic. Let's just real quick before we talk more about this, let's see if it works.
Okay, so let's go to the oscilloscope.
So you left your 2 input channels connected, channel 0 and channel 1, connected to the input and the output of the op-amp.
That's right.
And
so blue is the output, and you can see green, you can barely see any variation on that. Now notice how it's sitting.
That's me whistling.
Notice how green is sitting in between 0 and VDD.
Mm-hmm.
It's being set due to the negative feedback and the bias and the non-inverting input.
Basically applying that golden rule that says that the feedback is going to try to bring V plus and V minus to be equal to each other. Cool.
Yep, so we got our amplification.
Okay, so that's great. I think we should digitize.
Okay, let's grab the MSP430.